So let's have a look at this simple array problem, simple array operations. I'm going to go first of all through the problem description, context, tasks, steps, sample input and output, the hints, and then the submission, and then we're going to attempt a solution. So the context is we're dealing with basic array operations in C here. We're going to focus on input, output, sum and search functionalities. And the array size is fixed at 5 integers. You also notice there is no indent here. So one of the things we can do in our solution file is we can create a startup metadata instructions here, which is overview, hide blocks and indent. Especially the indent is going to be useful because if you run this with Ctrl+C, Ctrl+C, you can see that everything is being indented. So what are the tasks to carry out in particular? We want to read 5 integer numbers from the user, so some form of keyboard input is required. We want to display all the numbers. Then we want to calculate and display the sum of the numbers. And we want to search, asking for a number and checking if it actually exists in the array. So I'm going to open the next one, the steps, and these steps could be used to structure the program itself. Declare an array of size 5, use a loop for input, use another loop for display and sum calculation, and then implement a search function using a third loop. So there's a declaration, an input to define the values and put the values into the array, and then 2 loops to sum up and do the search. We're going to take those in turn, building it up from the beginning. Here's a little bit of sample input and output. So for example, an initial array of integers could be 4, -3, 100, -1 and 1. And the number to search for in the array could be 100, and then the output would first of all mirror back the array that we entered, give us the number of array elements, which in this case is 101. We would ask for a number, the number is 100, and the program returns that the number 100 was found in the array and even says how many times it was found. That's it. A few hints. Remember to write a program first that initializes an array in the source code. So do not attempt to do the user input first. User input from the keyboard is more difficult. So we have a first version of the program, just the code without user input, until we are sure that the summing and the searching work. Also remember that whenever you write a line of code that can execute, you should try to run it and activate the compiler to make sure that the syntax is right. And you should also save your file with Ctrl+X, Ctrl+S. The last one is not so important, but the other stuff, running your code line by line, is really important. It's important because that's one of the great advantages of using Emacs for this. It's a compiled language, so you can actually check your code as you go along, instead of having to wait and then having to debug the entire program. When you're sure that the algorithm works, the second part is to create a bash code block. And in this bash code block, you compile the program, create an executable called main, and you run this executable with a pipe symbol so that you pipe the array elements from the left into the program on the right, and then you'll get the output. If you don't want to do that, you can of course run these 2 lines in an E shell or in an Emacs shell as well. But you have to create a main.c file. We are doing this in an org mode file, so you have to tangle the file and create a main.c file. And lastly, once you're sure that everything works, you can try to generalize it. So you can make the array size more general by, for example, defining it at the start and keeping it open. But we're going to keep it very simple at first. I'm not going to talk about the submission right now. We're going to check that at the end, right? So leaving aside the hints, all of this is fairly clear. what I'm going to do is I'm going to leave open the tasks and the steps so you can follow those as we start the solution. So we're going to create another headline here for the solution. Leave the submission out for now and get started here. So we're going to use those steps that are shown here at the beginning. Declare an array, use a loop for input, then use another loop, and then use another loop. Create another headline. First code version 1 is without user input. So create a code block. It's a C code block. Now if we want to use to run our code in here, we have to have a line at the very top. So this one, test program would be hello. This one will bomb badly. It will not print anything because it doesn't recognize the print, actually not even C, so it doesn't recognize this one. And you see there are lots of mistakes. And the reason, if you get that, the very first error message here, implicit declaration of function printf, this means that the printf function is not recognized. And that gives you a tip in the next line that what's missing is the include stdio.h. But also there is no main program. So what you need to do is you need to go to the top of your file, if you haven't done that yet, and add a property line and run it. Alternatively, you can add that code that follows now in every code block. So the header arguments are valid for the C language, and we want to have a main program included without having to write it, and we want to include the standard io.h file so that printf and scanf are defined. And then lastly, we would like to see the output in the file. Yeah? So this line, when you add it in a file, will not be recognized. If you go out of the file and then you go back in, it will be read, but right now it has not been read, so we need to run it. Local setup has been refreshed, and you see that the font also has been reduced, so we need to bring that back up. Okay, so now this will work. As you can see, hello will work, and we can begin. We're actually going to reduce that because we have the steps, and the steps is really the most important part. I could even go and move that down here so I have it all the time and don't waste so much space. And now let's begin with the program. Now the very first thing we want to do, because we might begin the code and then go back to it, we don't want to have to read through the whole stuff, so we're going to prefix this with a header, a little header that says what this program is about. So our program is analyze, sorry, it's not temperature data, sorry, I'm on the wrong file here. So get an integer array from user, print it, sum its elements, and search it. Here we're going to put that all on one line. And this is a customary way of putting a header in front of code, and then search it for a given number, and you put your author's name in here. So this is a program I designed, and I'm going to make this publicly available using the GNU public license version 3. And this is version 1 of our program. So that's it, that's our header. Now we can copy this line, and that's the header. Okay, and we create another version, then this one we carry over, and instead of version 1 I will write version 2. So the very first thing we want to do is declare an array of size 5. there's different ways to do this. Let's not use the most general. Let's generalize this a little bit, and remember that if we define an array and we're going to loop over it, we need to use the boundary of the array quite often. So define the array size at the start as a macro. Define array size, and we're going to use the macro define size 5. And the meaning of this is that wherever the keyword size written exactly like this in upper caps appears, it will be replaced by the number 5. So our first action is variable declarations and definitions. And the first thing is the array. So we're going to call it A, and it has length size. And we're going to initialize it at the beginning with our sample input, which we need to get from here, which is this array here. Just going to copy this, mark it, and copy it. That's really all we need here. I'm going to put this in here. This will not work without commata, so separate them by commata, and this is a way of initializing this array with 5 elements. I already made a little mistake because I've said whenever you write a line of code, you should run it. And of course that counts for the comments as well. So I'm going to run this to make sure that there's no mistake. I'm going to add the definition, and there's no mistake. In this case, I don't actually need the size because I have 5 elements here. And then the compiler automatically knows that this is an array of 5. But I'm going to put this, I'm going to put this here in any case because I have made the decision that this array is array size, and so I should qualify it here as well. Otherwise, a user would have to go and check out, well, how many elements are these? Yeah. So the next thing is, I'm not going to do the search yet. I'm just going to do the first thing, which is the sum. In fact, I'm not going to even do that first. Yeah, I need various variables. I need a loop variable, so that's my loop counter. If I define it here, I can use the same loop counter in all the different four loops. Then I need a sum, so that's going to contain my sum, and I'm going to initialize that to 0. So this is the one of the output elements that I want. Remember, I wanted to sum up the elements of the array. The other thing is I want to search it for a given number. So I'm going to put the number in here as well. And I'm going to fix that with the sample values. I can later make it more general, but for the time being, I just want to make it specific. So this is input. So I have some output and some input. And better would be to reorganize this the other way around. Actually start with the declared array. So this is the array declaration and definition or initialization. Then I have the search variable, I have the sum variable, and I have the loop counter. If I have another variable which I'm going to introduce later on, which is called found. So if I found the function, remember my task up here was to ask for a number and check if it exists in the array. And the sample output says 100 was found in the array so and so many times. So I'm going to need another variable called found in here. And I'm going to initialize that to 0, which means not found, while 1 would be found. So this is what's called a flag variable for the search. Yeah. 0 means not found. Okay, I could have, of course, saved space and put all these variables, all of these, they're all the same data type. I could have put them all on one line if I wanted to save space. But then I can put comments in. Now this is a rather over-commented file. Later I might remove those comments, but for now this is quite self-explanatory. So I've got all my variables that I need. So first of all, let's sum and display array elements. That was my first task. I'm going to put my code, my comments in here to make sure what I want to do. I want to then display this summation result. I'm going to do a little bit of planning here. Then I want to search the array for user with a loop. For a given number. And we know what the number is. The number is called search. And we know that the summation result is in a variable called sum. And we know that the array is called A, elements of A. Okay, those are the three things we want to do. We need a little bit more at the end, but we can put that in later. Let's begin with the summing and the display of elements. And of course, there are three loops over the array, and the loops will all be exactly the same. They run from the beginning element to the end. And so I'm going to start by we're going to look at we can look at the output right now, but we can also just do this first and then adjust the printing out. Okay, so first of all, let's just do the loop for I equals 0, I smaller than size. For every iteration of the loop, increase the loop counter by 1. And here, first I'm going to display them. Actually, I'll go the other way around. Display and sum elements of A. I'm going to start with the printing. This is an integer array, and we're going to print the elements next to one another, A of I. So this will print all the elements. Print each array element per one array element per iteration. And the next thing is the sum. Now the sum was initialized to 0, which is proper, because we want to add the first element to the second, to the third, to the fourth, and so on. In each iteration of the for loop, one element is brought up. So what we want is we want the sum to be the initial sum or the result of the ith iteration, and add to that the next element, like that. Yeah, so this means store sum over array elements. Now, the way you will often see this written is in a shorter form. It's the same thing as sum plus equal A of I, which some people prefer because it makes it clear that every time you go into an iteration, an element of A is added to the sum. This one is actually would make more sense in a language like R, where you could write something like that. So the sum plus AI goes into sum. And that's it, really. So as you notice, I did not follow my own rule. I did not actually run this stuff. I should have run that. I'm going to do that now. I'm going to delete that and just run that to make sure everything is okay. So there were no mistakes here. And this is wise, because let's say I forget a semicolon or something, immediately I would get a mistake and I can fix it. before having the whole entire program. So I'm going to put that back what we already wrote and going to run that as well. And here I have my first answer. Now here I computed the sum, but also I could take that out and I would get the same result. Yeah, so I'm printing every element of the array, then I'm going to sum over it, and now I want to display the summation result sum. And that's easy. I'm just going to write a print statement, sum stored in sum. So sum is 101. I'm going to put a new line in front so it looks like that. Now this doesn't look yet like our final result, but if you're fast, then you can of course make it look exactly like the final result, but just for the time being we're going to make it a little simpler. So we got the sum here. Let's do the next one. This is the first result already. So actually, you know, since we are at it, why not do what we actually needed to do? So let's have a look at sample output. So what we really want is something that looks like this. I'm just going to copy this here into our solution. So what we want is something like this: array elements entered. So we can put this in here, printf array elements entered. No new line here, just like that. That already looks very good. And then the second one is, instead of just writing sum, we want to write sum of array elements equal 101 dot. Looks good. Looks exactly like what we want. And now we can delete our example here. And so we have solved the first part of the exercise. Now, the next part of the exercise required a little more different kind of algorithm. We now want to search through the array. We have a given number and we want to check if the array contains the number 100. So to do that we need a loop again. And in the loop we need a condition, a statement that says if the number, the element of the array we look at right now is equal the number search we're looking for, then let's do something. And since the output we want, I'm just going to go back here, includes, as you can see, both the information that 100 was found, but also how many times it was found. So that means we need to store this number here. That's the number that I called a flag here, right? So flag means it's been found, and we can add that number up. So if we found it 15 times, found should have the value 15. Yeah. Let's do that. Let's do another for loop. We could now copy this loop if we didn't want to write it again. And I don't want to write it again. It's the same loop. And we need a condition. So if a of I is equal search, the number we're looking for, then increase found by 1. Yeah. Array element is equal to search. And then increase number of findings by 1. However, if not, then nothing. Yeah. So we don't actually need the we don't need these curly brackets here at all. We can just do it like that. However, I like to use curly brackets because sometimes you want to add another element, and then you will have to figure out which elements are in this selection and which are not. So it's too easy to make a mistake here. It's better to do it like that. Now, before we can check our for loop, we have to close it. You can see what Emacs does here. If you use it right, it actually will jump back and confirm to you that you've just closed a for loop. So this is worth running. So I'm running it. Everything is fine. And let's reconsider what happens in this loop. Okay. So the for loop means I'm going to the element A0 and I check if it's the same as search. Then I go to the element A1 and I check if it's the same as search, and so on. And every time this condition is fulfilled, I increase the found flag, the found index, by 1. So all I have to do now is print out the number of findings. So let's go back here and let's go and copy this output again, because that's what we want to obtain. And so before here we have the same thing as before. We have a print statement. In this case, we don't have an input yet. Which number should I search for? We have not input this number, you have just given it. So the number is search. Okay, you can run that. And the number is 100. And then in the then we need an output of the result. So this is the search routine, and then we need to print the result of the search for the number search. And here all we need to do is if found is equal 0, so the number wasn't found at all, number search is not in the array, then print was not found in array. And otherwise, if found is non-zero, then we can use that and say search was found in array. And how many times? It was found d times. So here we need two arguments, search and found. Okay. Now here I've suppressed the curly brackets. You can also put curly brackets in. Then you have a curly bracket after here, and at the end of this, and here, and here. So this will be the same thing. And let's run this. We've got one too many new lines here. I don't think we need this one right now. There we are. Yeah, so which number should I search for? Of 100. 100 was found in array 1 times. So here we have solved our problem without user input. This is just the first version of the code. Okay. So I don't remember how long this took. Let's have a break. So this took 30 minutes to develop, but with a lot of explanations, of course. I'm going to go to the next version to add the user input, and there's not much to be done here. Just recognize that the main algorithm is set, right? We have decided to put our numbers in an array, then we have a bunch of different variables which we want to, we have some input variable, we have an output variable, and we have two counter variables. One is used in the loop counter, the other one gives us the number of times the search was found. And then we have our three loops. The first loop, this, and actually there's only two loops here right now. I don't know where's the third loop. Anyway, so now, how do we proceed? We proceed by copying our code and then changing it accordingly for user input. Yeah, and then I might give you a third version in which we streamline the code, but really we want another version just with user input. So I'm going to make another headline, code version 2 with user input. And there's nothing we need to change about the algorithm whatsoever. So we can close that with tab, mark it, copy it. I'm going to put it in here. And this is version 2 with user input. And now let's see what we need to change. Question, do we need to change anything about this? And the answer is yes, we do need to change something about that because we don't want to initialize it explicitly. We want to initialize it with the user. So now this here is input. It's an array declaration for input. That's the first change. The next change is that we need another loop. That's the third loop I was looking for and couldn't find a moment ago, which is we need to get user input. Usually this starts with a line like enter 5 integer numbers. We could actually make that more general if we want. Enter the integer numbers. The D, of course, is size. And then we need a loop. We have a loop variable, so we can use I again from I equals 0, I smaller size, I plus plus. And this is now an input loop. So we're going to use the scan function, not the print function. Scanf %d, and then we want to input array sizes, array elements, but we need to remember that the scan function requires an address of operator. Now the testing of this may be a little hard because we could put the testing block in right away, and that's probably the best idea because we know all the rest of the code will actually work. So we added this and none of the other stuff should not work. In fact, if this works, then the rest of it will probably work as well. So we're going to go, after we added this, we're going to leave this for now. We have to later add more user input and just dedicate ourselves to the array input. And we're going to write a testing block. So if we run this file as it is right now, that's a bit, I'm going to make it a little smaller. You can see the result. We just go here and make that like that. If you run that, you see enter 5 array numbers, integer numbers. It jumps to the next one, array elements entered, and these are just random elements in memory. So the algorithm doesn't work because we haven't entered proper numbers. The sum of array elements should still be okay, but I don't want to check that right now since they're nonsensical numbers. So if I run that again, I get other values. Every time I run this block, I get other numbers. And you should know why. Because at the moment, we're not doing anything. We're just scanning existing places in memory somewhere. So to do this right, we need to not run this code block, but instead we need to write a testing suite. Test this on the shell. We need a shell block. I'm going to write this. You can write a normal source code block and add bash instead of C. And then all you need here is, if you want to see results, write results output. And the first thing is we want to run this file. Of course, we don't have a file yet. We're going to call it main.c, and the output file is supposed to be main. Now this will not work because we don't have a main.c file yet. All we have is a code block. So we need to go to the top here and tangle this code into a file called main.c. Yeah. Test this on the shell after tangling the code block, the source code, with Control U, Control C, Control V, and T. Now that looks like a mouthful. I'm going to explain this again. The first one is an argument, just that means do only this code block you're on. The second one, Control C, Control V, stands for tangle the code block. And so if you run this, Control C, Control U, you can see it at the bottom of the file. Control C, Control V, T, one code block was tangled from simplearray.org. I'm just going to check that that's the case. I'm going to look for the file, Control X, Control F, main.c, and here's the file we just created. Yeah, that's our file. It's got some white space in here, but there it is. Just like we wrote it just a moment ago. I'm going to go back to my org mode file, and now I'm going to run this, which all it does is compile source code into machine code file, or also called an executable main. And there were no mistakes, no errors. So we can now run this. We want our array. We've lost the values probably, so we need to go back and look at our array elements, these guys. And that's the only thing we are inputting here right now. So we're going to go and echo these numbers and pipe them into the main file. So this means put the output of echo into main and run that. So let's see what happens. Yeah, looks pretty good. The numbers were accepted, the sum is right, the number to search for was found 1 times. So the only problem here is the output misses a new line here, which we can fix really easily. We can put a new line in front of this print element. And now if I run this again, I'll get the same result because I have not tangled this. So I need to go back up in this and actually tangle the file again. Tangled one code block. Now the new file will have a different output. Yeah. So I'm going to go through those steps very quickly again. I had the source code. I added an input section. Now I want to, if I want to run that, I need to go on the shell. I need something like this. I have an alternative, but whatever I do, I need to tangle this into a main file. I'm just going to show you the alternative because I mentioned it in the program assignment, and then we're going to go on and move check the second part, because we still wanted to get a user input for the search number. We haven't done that yet, I think. Yeah, we're going to do that afterwards. But first I'm going to show you this again. So we have to tangle the file. I'm going to do that again. Control U, Control C, Control V, T. I tangle the code. And then I'm going to go to a shell. I'm going to open a shell in the same directory, hopefully. This directory is org, so I'm going to go into org. And in org, I'm going to check that I have the file main.c. It's not there. Why is it not there? Oh, because I'm not in GitHub org, I'm in just in org. So I need to change to ~/org. And here there should be a file main.c, and there it is. Created just now. Now we're going to do what we say here in the file itself. So I'm going to run that on the shell. GCC main.c -o main. We have the same result. That's very nice. I'm going to check that I have this file. And you see I have different files now. I have a main.c and I have an executable main. And now I can run the file main. Now I could either copy this line here and run this down here. We have the same result. Or I could run main and give the input bit by bit. So enter 5 integer numbers, 5, -3, 100, -1, 1. And the 100 was set, so the sum of elements is given, and the number to search for is also given, so that second part doesn't work yet. Yeah? So that's what I also could do. And you can see that it is much easier to do all of this in the org mode file instead of going back and forth between different buffers. So I'm going to go back up at the top, and we need to finish the second part of our code, which is not set this number, but have it as input. So we're going to delete this and its proper input. So input number to search for in array as input. Now we need to get that number and have another section here. Ask for a number to search in array. And same thing, printf, actually we already have that down here. Which number should I search for? But we're not giving the number now, we are asking for it. So this is just a print statement. And now we get the number, get number to be searched for array. And that's a scan statement. There's no loop here because we're just getting a single number. And the number is search. Yeah, so the number search here is uninitialized up here, just declared. And down here we're going to initialize it. And from now on the number is known. So once the number is known here, in fact it would be better to once it's known, we can now run the second part of the program. Yeah. Now there's two different philosophies. We could either get the user input in this block and then do all our computations and then give the output, or we could make two parts of the program. I think I'm going to do this for now. Okay, so I'm going to take this part and move it down here. So we have two different parts of the program. The first part is get the user input for the array, sum it, and then print the result. The second part is ask for the number to search for it, and then print out the result. Yeah. With regard to our test block, nothing changes. So we haven't made any mistakes. The only thing that changes is that, sorry, there is a change, because down here, instead of only asking for the array numbers, we also need to ask for the search number. And if you look at what we did here, first we're going to ask for the 5 elements of the array, and then here we're going to ask for the number. So in the echo, we need to add this at the end. If we want the number 100 to search for, we need to do it like that. And so let's see if that works. We need to tangle our file and then run it. And there's a mistake. Let's see what it is. It's a segmentation 4, so that wasn't very good. Oh, you can see what happened. Okay, let's go look up what I forgot here. So look at that command. Think about what the problem may be. Segmentation fault usually means that some memory thing was done wrong. And so what happens here, you can read that here, is that what was expected was actually a something that has to do with pointers and addresses, and we forgot that scan wants an address. It wants an address to the location of search and not the value of search itself. So we're going to tangle that again, go down and run it and hope that it works this time. And yes, it does work. Now we've got a duplication here. I'm going to put a new line at the end of this. Tangle it again, run it again, and now we can compare with the output that we actually wanted. So I'm going to split the screen, and at the top I'm going to have a look at the sample output that we wanted to get and compare. And here you see it is. So array element entered. The only difference here is that enter 5 integer numbers shouldn't be in there. So I'm going to take that out, and otherwise everything else I think is fine. So I'm going to go down to the code to align that and just comment that out actually. Do that again, run it again, and here we are. Now we've got a new line too much. For some reason, I think it's this one, yeah. Run that again, and here's the result. Yeah, so this is our code. You could create a third version of this code if you wanted to, but the assignment asks for 3 loops, and you have those 3 loops here. One loop to get the to assign the values to the array, a second loop to display and print and compute the sum, and a third loop to search for the element that you were supposed to search for. So you have 3 loops, and that's what you should keep. A shorter version you will find in my sample solution, which I will give you. The other thing you were supposed to do in the submission, let's have a look at the submission, is to create an org-mode file complete with title, author, subtitle, and so on. I trust that you know how to do that. And a startup line, which we added. You were supposed to write a short description of how you tackled the problem. Minimal comments. The comments here are not really minimal, they're pretty extensive. You could keep them shorter. The header argument, we added that. You can tangle the file with mx org babel tangle. Let's see if that works as well. Org babel tangle. Yeah, that works as well. And then you must pass the test case, and that the test case we worked with all along. Yeah, so this is would be in terms of the code already a good solution. I'm not going to show you the entire file. You can look at that in my sample code later on. And that's it. Now let's see how long that took. So there was another 20 minutes or so, so 50 minutes for the entire thing. And that's not too little for such an exercise, I think. The next one is going to be a little longer, but you get get that in a separate video.